Alright, well, welcome back. Our topic today here is slope field insanity. And that might be a little overkill, but again, we're going to really nail these slope fields today. So I just want you to think the whole time we're going through this, that the slope field is really a graphical solution to a differential equation. It is a field of slopes for this equation. So let's go ahead and attack our first problem here. Let's say dy dx equals x over y. Okay, so again, you could separate the variables and integrate and get your solution, and that's all great. That's probably going to be part B to the problem. But part A is just to graph this slope field. So, and we'll just use, let's go -2 to +2. We'll make it a little nicer on ourselves. Alright, so again, we'll say we're -2 to +2. And I'm going to say x's versus y's here. Alright, so pause it, you're on your own, fill in your chart, and then we'll attack our picture. So again, hopefully, you've timed yourself, and maybe you got it down to less than 2 minutes. If you can do it in under 2 minutes, you're in great shape. If we're talking 5 to 10, we're in a little bit of trouble, because this should be the nice easy part. So really work on that speed. That's one of your goals today. So now that we have our values there, let's go ahead and we will graph this from -2 to +2. And I'll put my dots in, and hopefully you've got some paper. And again, go ahead and graph your slope field and then compare to mine. So pause it and graph your own. Alright, so let's just check a few things. Let's make sure that our horizontal slopes are here along the y-axis here, except that crazy point at the origin. Remember, the undefined always beats out that 0. And we've got undefined slopes here, and watch that relative steepness. I can't stress those words again, relative steepness. Make sure your slope of 2 is steeper than your slope of 1. That 1 is steeper than a slope of 1/2, and etc. So now we're going to go ahead and answer some questions based off this graph, so keep this handy. Alright, question 1. Describe all the points in the xy plane for which the slopes are positive. So they're asking for slopes, obviously, and they want them to be positive. So I'm just going to look at my slope field that I drew and just ask myself, where do I even have positive slopes to begin with? Well, I would definitely say quadrant 1 here, they're all positive. 2, they're negative. 3, they're positive. 4, they're negative. So I definitely need to describe quadrants 1 and 3, and that's how I'm going to do it. I'm going to break it up into steps. So I'm going to go ahead and say quadrant 1. And here's kind of the goofy notation we want you to use that they'll be expecting to see. I'm just going to open up with a bracket, and I'm going to say all the points, so x comma y, such that, so if you're not familiar with that nice line, that's your such that line. Now, how would you describe these points? Are they in, let's look in that first quadrant again. They're all clearly above the x-axis, and they're all to the right of the y-axis, so I would say two things. I would say your x values have to be positive or greater than 0. And your y values have to be greater than 0. So I would describe that in 2 ways. So let me just say that one more time. The x values are positive, so this is describing the first quadrant, and my y values are positive. So when I do that, I'm describing everybody in that first quadrant. Now I'm going to do the same thing. I need to talk about the third quadrant as well, because I also have positive slopes there. So again, I'm going to say all points x and y such that. And if I wanted to describe this quadrant, how would you describe your x values? Well, I would certainly say my x values are less than 0, and so are my y values if I'm talking about that third quadrant. So this will answer the question for us, describe all the points. So they didn't want a sentence, they wanted mathematical notation, of course, that describes all of these points where you will have positive slopes. Alright, let's attack a second question. So the next question is very similar. Describe all points in the xy plane in which the slopes, that should say, are negative. So it's pretty much the opposite of what we just found. We want to describe the slopes, but this time we want our slopes to be negative. So hopefully you're saying, okay, I would be in quadrant 2 or in quadrant 4. So I'm just going to describe each one separately. In quadrant 2, I would say that's all the points x, y, such that. Now how would you describe quadrant 2? Your x values are certainly less than 0, and your y values are greater than 0. And then likewise in quadrant 4, maybe you could pause it and rewrite it yourself and then check back with me. I would definitely say the x values are greater than 0 and the y values are less than 0. Alright, third question. Describe all points in the xy plane for which there is a horizontal tangent line. Alright, so a horizontal tangent line obviously is a line that looks like this, has a slope of 0, and I think you can easily see them. Let me highlight them for you. I would say they're all kind of sitting on the y-axis, which basically is telling me their x value for each one of those is equal to 0. So I'm going to say x is equal to 0, but now there's one little hiccup. It's not at every time x equals 0 because there was that nasty piece at the origin there. So I would say at x equals 0 and then basically y cannot equal 0. Okay, so every time there's an x value of 0 you have a horizontal tangent line except when y is equal to 0. And lastly for this question, describe all the points in the xy planes for which there is a vertical tangent line. So again, I'm looking for my line that looked like this or where my slope was undefined. And I think you can easily see that along the x-axis here. And what's special about the x-axis is that where every y value is equal to 0, you will have a vertical tangent line. Alright, so here's rather a lengthy question to go along with the same set of problems that we just had there. Let y equals f of x be a particular solution to the differential equation with initial condition f of negative 2 equals 1. Write an equation for the tangent line to the graph of f at x equals 2. So a lot of people get way too excited about this. They see particular solution and they want to separate the variables and integrate, and you're doing way too much work. Basically, they gave you the whole point. F of negative 2 equals 1, so they gave you x and they gave you y, and all they want is a tangent line. So you have half the battle done for you. You have x, you have y, all you need is the slope. And don't forget, that's what dy dx stands for. They gave you the slope. So all I'm going to say is this is y minus 1 equals, my slope is going to be the x value over the y value, so that's negative 2 over 1 times x minus 1. And that's it. That's all they're asking for. Perhaps there was a lot of extra wording there, but just look for those key details and you'll be successful. Alright, so our next question says, use the tangent line found previously to approximate f of negative 2.1. Well, a very, very simple problem here. We're just going to take this equation we have and we're going to substitute in negative 2.1. And hopefully you've come to realize by now it's probably... I think, I made a little mistake there. I think this x value should have been negative 2. I apologize for that. Hopefully you caught that and are yelling at me. I'll put my negative 2 in here. Oh crud, which should now make that a plus 2. Sorry about that. So this should actually be a plus 2. Alright, back on track here. I think you'll find it's easier by now is instead of distributing this negative 2 is if you actually add inside here first will make your mental math a lot easier. So I've got y minus 1 equals negative 2 times negative 0.1. So I've got y minus 1 equals positive 0.2, add my 1 over, y equals 1.2. So what is that telling me? Well, that's implying, therefore, f of negative 2.1 is approximately, notice I'm not saying equal, I'm approximating 1.2. And the last question to this little piece is this an under or over approximation? Now, I just want to know how we would solve this question. How would you know if a tangent line is an under or over approximation? Well, hopefully in the back of your head you're saying, I would need to know the concavity of this graph. If you can picture, and just draw a little picture for yourself there, if I'm concave down, I think the tangent line is a very easy, sitting above, so it would be an over approximation. If I'm concave up, my tangent line would be an under approximation. So I think you would say we could do this. For lack of time, I'm not going to take it and find out, but let's make sure we understand how to figure it out, that we're all talking about concavity. Alright, so we're going to take the time and we're going to do one more question together. So I'm going to give you this slope field, or this differential equation, dy dx equals 1 minus y over x squared. Really time yourself. See if you can do this under 2 minutes. Fill in this table as quickly and accurately as you can. So pause it, do it on your own, and let's see if we match. Again, try to be under that 2-minute mark. So hopefully your table looked like mine and your slope field like mine as well. Your zero slopes are where they're supposed to be, your vertical slopes are horizontal slopes, your undefined slopes are where they're supposed to be, and watch that relative steepness. And lastly, just make sure you're aiming at something. You know, when I have a slope of 1, make sure I'm rising 1 and running 1. So right here, my slope of 1 should be aiming at my 1 point. I should have it, you know, something to aim at to make this very clear. That's what they're going to be looking for. Alright, we're going to answer the same questions that we previously talked about with the other problem. So the first question says, describe all the points in the xy plane for which the slopes are positive. So I just want to stress that the xy plane is inferring that if this graph were to go to positive and negative infinity, forever and ever, we need to describe all of those that have positive slopes. So if you just look at it, these are negative, these are 0, undefined, and then everybody down here is positive. So basically, and keep in mind, even here would be a positive slope, here would be a positive slope. You're positive until you get to this horizontal asymptote. Okay, that's where those slopes are 0. So everybody's positive as long as your y values are less than 1. Notice you can't equal 1, you would then have a 0 slope. And then we would have to exclude something. Clearly I don't have positive slopes here, these are undefined. So I'd have to say x cannot equal 0. Alright, second question, find all the points in the xy plane for which the slopes are negative. Alright, so we're just kind of doing the opposite. We just said that they're negative when they're above that line 1. So I'm going to say my y values are now greater than 1. And again, the x values cannot equal 0. Third question, find all the points in the xy plane for which there is a horizontal tangent line. Okay, so I'm looking for slopes of 0. So if I look at that, I can basically say anytime my y value has a height of 1, I have a horizontal tangent, except x cannot equal 0 because there's a vertical there. And lastly, describe all the points in the xy plane for which there is a vertical tangent line. Well, those happen right on my y-axis, so that happens every time you have an x value of 0. Alright, well there you have it. That's all I have for you tonight. So again, we'll just get to class and we'll get busy here practicing, and we'll look forward to seeing you tomorrow. Have a great night.